Yeah, hi coders. So welcome to the channel Java Hello World. So today we will discuss about the topic which is how to optimize the API performance. How can we increase the performance of the API, which will be helpful in the cost cutting as well as to get the response of the API in the short interval of time. So it is a very much frequently asked question by the interviewer in the interview perspective. So let's start this topic. So here, coders, like I have written this. So how can we optimize the performance of the Java application? First of all, we need to do the database optimization. So in order to do database optimization, what we have to do, we have to add proper indexes to frequently queried columns. So suppose we are querying the columns every time. So to querying it, we can create the proper indexes so that it will query through the index itself. So it will reduce the time taken time taking to fetch the data from the database. So we can directly call it through index. Now we will do avoid select star. We need to avoid the select star and specify only required columns. So every time we can see that we are using select star. So that time what it's happening is like it will give all the columns, whatever means not necessarily columns as well. Like we don't require that as well. So like to avoid that situation, we will not use select star. Instead of this star, we will use the specific columns so that we can directly get the specific columns into that. Now, the third point. Third is something rewriting the joins and subqueries for efficient original query. So we can means refactor the queries and the joins. Like we know that if we will join the tables, the two tables, like suppose if we have the two tables from there, we need to face the data. So if we'll join that, it will be all together. So it will be very efficient. In the efficient way, we can fetch the data. So that is something rewriting the joins and subqueries for efficient original query. Now, like we can means join this through internal join, through right outer join, left outer join, like that we can do that. Now introduce the caching using Redis for frequently access data like product catalog and the user preference. So suppose uh, if we have some use case, like the use case is something we are developing a shopping website. So there we need to show every time the product catalog as well as user preferences. So suppose some user have some preference, like he or she wants to add that in the catalog. So you see, he or she wants to get that particular things, particular products from the page. So that time we can use user preference and we'll get that through the user preference. We so what we are doing, we are every time we are hitting the database. So instead of hitting the database, we can directly get that from the cache. So we can use that introducing cache using Redis. So from the Redis we can introduce the cache and we can face the product catalog as well as user preference like this. So I am just giving you the example. Even if you have some other use case, so you can directly correlate with this use case. Like if we are hitting the database multiple times, it will be very costlier and it will take much time. So to avoid that, we are using the caching principle as well. Okay. Now there is some code level of, so these 4 points are from the database optimization. Now there is code level optimization. So how can we do code level optimization? Firstly, use the string builder to reduce the creation of object by using existing object. So we can reduce the creation of the object by using a string builder. Means while we are doing that string, then every time we need to concatenate. So that is not the good practice. If we will do string builder and then we can directly append that, that will be a good practice. And then in the final whatever concatenation we done, means we whatever appending of the particular string we have done, then we can directly convert that string builder to string. So that is something a useful way, the efficient way to have the code level optimization. Okay, now there comes the optimized loops and use parallel streams. So we can do the parallel streams. So we can see, like, suppose if we have the uh, loop, so in that loop we have suppose 1 lakh count. So through one, starting from one, we need to count till 1 lakh, and then from till for each each of the value of I, we need to print that. So it will take lots of time. So to avoid that, we will do like a parallel stream. Instead of doing the stream, we can do parallel stream. So it will reduce the time to and having the CPU intensive. So it will optimize the CPU as well. Like it will give the performance in an efficient way. So now the third point is minimize the usage of synchronized blocks by leveraging concurrent hash map and other thread safe collections. So minimize the usage of synchronized blocks. So we can minimize the use of the synchronized blocks. Like we can see, like in the collections we are sometimes using the synchronized. No, we don't have to use the synchronized block. For the thread safety purpose, we can use concurrent hash map. We have already concurrent hash map in the collections added, so we can use that to optimize this code level. Now, for improving the API performance. So here it comes the for the improving the API performance. So why, how can we improve the API performance? This is something about code level optimization. Now the API performance improvement. So we can improve this, like introduce the asynchronous processing using completable feature for non-critical tasks such as logging and sending emails. So suppose we can use the asynchronous feature, asynchronous call. So suppose user already placed the order, and so in the shopping website, suppose user already placed the order. Now, if you are if you are thinking that if the order will be delivered, then the mail will be triggered. No, means just right away after the order has been done, we will directly send the mail to the user that the order has been created. So it will not wait for the delivery things and all. So that kind of thing is something asynchronous call. So that time we can do the asynchronous call in this. Okay, now the batch multiple smaller request into a single API call to reduce network overhead. So we can batch the multiple smaller request into a single API call. So like we can directly hit the repository with the IDs, like find by ID, find all by ID, like that we can do in the single call. We can collect in the API. Now we have to do like added gzip compression for API responses to reduce the payload size. We can do the compression g means we can zip the file to reduce the payload size. Now scaling the infrastructure, so we can scale it. Like we can create the load balancing with multiple application server instances. So if the particular load is more in one server, so it will go to the another server. Like that we can create the load balancing of that server. So now it comes the deploy of a CDN, the continuous delivery network. So we can deploy the CDN for static resources like images and scripts to offload traffic from the application server. So we can means suppose the images is there and the scripts are there, so we can directly off means deploy it in the CDN. So it will give the directly the content. Like suppose in the YouTube also, means it's impossible to get the content so frequent way in a frequent way. Means we have the means there is the feature which is CDN, the continuous delivery network, where from which from that technique, like that tool, we can get uh, the content means frequently. So like that, we can deploy the CDN here also for the static resources. Okay. Now there is something testing and monitoring. So how can we do the testing and monitoring? By first of all, we can do that Prometheus. Say we can set up the Prometheus or Grafana for the real-time monitoring of the application performance. focusing on matrices like response time, CPU, and memory usage. So we can means integrate the Prometheus or Grafana in the pom.xml. Like we can add that, and we can see the real time response of that, and the memory usage, the focusing on metrics. So we can focus on the metrics like response time, CPU, the memory usage. We can do that. Okay. So likewise, this is something about the that our testing and monitoring. Now we have the profiling the application. So we can profile the application using use tools like JVisual VM and your kit to identify the bottlenecks in the code. So we can use tools like JVisual VM virtual machine or some kit to identify the bottlenecks in the code. Then observe that certain database queries were taking an unusual long time, and that garbage collector was frequently running due to high object creation. So like that, we can optimize that. And how can we check the quality of the code? We can check by using the Sonar. The vulnerability we can check by Veracode, and the Black Duck 45 scan, like that we can do that. So we can means through this kind of things whatever I explained. So from there you can increase the performance. We can increase the performance by reducing the time from suppose we are getting the response in the second, so we can reduce it to the 300 millisecond, like that we can do. As well as we can save lots and lots of money by getting data without hitting the database every time. Okay, so this is something about the optimization of the API performance. So how you like this video? uh, just uh, just comment it, like it, and subscribe my channel. We'll meet in the next video. Until unless, bye.